Hello, good evening, everyone, and welcome. You can see about 10 people are early today. Kudos to you guys. Okay. One, one, two, three, four, five. Okay. 5 of us are early today. Welcome, guys. Deborah, welcome to the call or the meet. Hikma, you're welcome. Labibat, you're welcome. Mukuma, you're welcome. And Salim, you're welcome too. Let's just give others time to join. So let's just wait for like 5 minutes is fair. Let's wait for 5 minutes, guys. Also, please make some reaction if you can hear me. Let me be sure my mics. Yeah. Thank you very much. Thank you, guys. So 5 minutes time, 6:08. We get started. Yeah, Mr. Deji, I was just waiting out latecomers. So by 6:08, I hope to start while I give that room of time for people to still join. You're welcome to the call, Deji. Hope you can hear me, Mr. Deji. Hikma, can you hear me?
Yes, sir, I can hear you.
All right. Seems Deji is not here. Okay, so about the attendance for last week. Okay, yes, true. Not to worry. Don't worry about that. It's sorted. So I took screenshots of everyone in attendance, and at the back end it will be everybody on in attendance will be imputed. So don't worry about that. It's sorted. But today, I will I will provide the link at the end of the class today so that we can all fill or sign our attendance. So don't worry, it's all sorted out. Okay. Hi, Salim. Can you hear me?
Yes, sir, I can hear you.
All right. Welcome to the call, Salim.
Thank you very much, sir.
All right. Labibat, can you hear me too?
Yes, sir, I can hear you.
All right. You're welcome to the call.
Thank you.
Hi, Deborah. Seems Deborah is not here. Mr. Deji, you say you can't hear me. Just try to rejoin again. Just uh log off and try to join again. I think the rest.
So I can hear you now, sir.
Oh,
I had
okay.
to restart my network. Thank you very much.
All right, you're welcome. Ibrahim, you're welcome to the call too. I see new people join. Mopelola, you're welcome as well.
Thank you, sir.
Yeah, you're welcome. Mr. Simon, you're welcome too.
Thank you, sir.
Yeah. Okay, it's 6:08. Let's get started, guys. And I'm hoping we don't close as late as last time. So let's just get started. But before I go on, please make some reaction if you've the project under unsupervised, like after the unsupervised learning course, if you've taken that course, like if you've taken the project rather, there's a project following. So just make some reaction. Only 2 persons. I only see Hikma and Deji. That means just 2 persons. It's three now. Mr. Salim, just three. Four, Mr. Ibrahim. Anyone else? Okay, so 4 people. 4 people only. Well, that's fine. That's fine. So that's exactly the project we'll be doing tonight. And there's one other project I saw on Data Lab, but that it's more of an advanced project. Although K-means clustering was to be employed as one of the means to get the project done, but there are still some concepts that we haven't touched yet that comes in later during this track. So I would have used that, but let me stick to this since this is the only beginner-friendly project I find. So now, let's quickly get started. This is the project we'll be dealing with today, and it is titled Clustering Antarctic Penguin Species. I believe we all know what a penguin is. This is the diagram. Here is a beautiful diagram of penguins. You know those birds that walk in a very funny way and they stay in a very cold environment, iced environment. So that's the project we'll be dealing with. So to get a brief of what we'll be doing, now this is it. you listening to me now, you have been asked to support a team of researchers who have been collecting data about penguins in Antarctica. The data is available in CSV format as named this penguins.csv. Origin of this data. The data were collected and made available by Dr. Christine Gorman and the Palmer Station, Antarctica LTER, a member of the Long-Term Ecological Research Network. Shout out to them. The data set consists of 5 columns, just 5 columns. This is the column name and this is the description of the column. The column name is Coleman length mm. And here's the description, Coleman depth. The third column is flipper length, body mass gram, that is measured in gram. There's the body mass of the penguins measured in grams, and the sex of the penguin, is it a male or a female? Then this describes, I think Coleman should be, let me confirm what Coleman means. Coleman bed. Okay. All right. So Coleman means the beak region. It refers to the beak. Beak, that is that mouth, the way the mouth is structured, that sharp edge. That's where the Coleman is found. So that's what this length, that's where this length is gotten from, and the depth as well. Then flipper refers to, I believe that should be their wing, that they flip. So those are the information provided to us in this data set, and it's what we'll be working with. And I encourage everyone to always get abreast with the data you're working with, like get to know what each column represents or what it does. Because during EDA, exploratory data analysis, it will be very, very useful. So please, guys, whenever you're working on the projects, I encourage everyone to always understand, go in depth, and look for the information or description behind your data set. All right, so unfortunately, they have not been able to record the species of the penguin, but they know that there are at least 3 species that are native to the region, named Adele, Chinstrap, and Gentoo. Your task is to apply your data science skills to help them identify groups in the data sets. Now, I'm going to ask a quick question. Who can tell me what kind of learning should be used to solve this problem? Given this last information here, which says, unfortunately, there are no labels. There's no record of the species in these data sets. All they have is length calculation or measurement, depth, body mass, and the sex. But they do want to know which for each penguins recorded, which species does it belong to? So who can just quickly tell me what kind of learning can help us solve this problem? What kind of machine learning will help us solve this problem? Anybody? You can raise your hand if you want to go. Anybody?
It's not unsupervised learning.
Also, okay, why unsupervised learning? Thank you, Hikma.
Okay, they said your task is to apply your data science skills to help them identify groups in the data set. And before that, they said the species has not been found, then the record of able to record they have not been able to record the species of penguin, but they know that there are at least 3 species. So and from what you said last week, you said unsupervised learning is like you are trying to get a particular data from an unlabeled one. Probably you don't know the ones before. How am I going to explain it? Okay, let's see.
Well, you've done very well, Hikma. You've done
I'm
well.
trying to explain it within this example. Okay, like you are trying to cheat algorithm to find patterns and structures within unlabeled data, something like that.
Okay, Labibat, have you been the one
Without
speaking
any.
so far?
Yes, sir.
Oh, you've been the one speaking. I thought it was Hikma. Okay, no problem. So, Labibat, sorry, you've
Yes,
done
sir.
very well. Yes, you've done well.
Yes.
Now, yes, the reason why we are using unsupervised learning to solve this, which you got correctly, because there are no labels we are dealing with. We have to be the one working out what this label should be. The machine should be the one working out what this label should look like. And in this situation, unsupervised learning is always the use case. This is where unsupervised learning comes in. Had it been there was maybe a target variable we were training this would be training the model on, and at the end of the day we have to predict further values under that target variable. There we have to use supervised learning, but in this case it is unsupervised learning we have to employ. Thank you very much. So everyone just give an applaud to Labibat. She have done very well. Please applaud her, encourage her, please. Thank you very much. Okay, so let's go on. These have already been imported for us, and I guess we might have to work with only these, or if there's any need for more import, we'll deal with that. But before we go ahead, the specific goals to meet are on the left-hand side. You can see on the left-hand side of the screen. Utilize your unsupervised learning skills to clusters in the penguins datasets. First, import, investigate, and pre-process the penguins.csv datasets. That's the first task or first phase. Second phase now, perform a cluster analysis based on a reasonable number of clusters and collect the average values for the clusters. The output should be a data frame named start penguins with 1 row per cluster that shows the mean of the original variables or columns in penguins.csv by cluster. Start penguins should not include any non-numeric columns. All right, that's our task, or those are our tasks for today. Let's get started. But before we go on, who can tell me the very first thing we should do? What's the very first thing we should do? Already our what's it called? The data set have been loaded for us using pd.read.csv. This PD is imported from pandas. This is pandas here, highlighted right now. It's from pandas. So pd.read.csv lets us read whatever is inside this CSV data set that have been provided for us. So please, okay, thank you guys. I can see some people are ready to go. Mr. Ibrahim, all right. What can we do first?
The first thing we should do is to use the pd.head to preview our data and see what we are dealing with.
All right, that's very, very correct. Very correct. So please walk me through. How do I do that? Today is going to be very practical and engaging. We'll work this out together. So, Mr. Deji, you want to tell us how to do it?
Yes. Okay. Yeah. Previewing the data is the most important thing. So we would use
Okay.
penguins underscore df dot head bracket. The head is the method. Penguins underscore df dot head. So we would look at our
Okay.
columns and we'll see the index, the Coleman length, the Coleman depth, the millimeter, the flipper length, and the body mass index and everything. So that's the first thing.
Okay, that's very true. That's very, very true. All right, moment of truth. Let's see if Mr. Deji is correct. The system won't lie. There we go. So it's correct. We can now see a preview of the data sets. We can see the very first column we have there is the index, like numbering each rows we have on the data sets. The next column is the Coleman length, like they mentioned, or like was mentioned earlier, the Coleman depth, flipper length, body mass in grams, and the sex. That's correct. So moving on, what's the next thing we should do, guys? Who knows the next thing we should do? Because before we engage on even training the model, there are certain things we should do as a data scientist and stroke a machine learning engineer. There are things you should definitely look out for or do before you start training. All right, please go on. Mopelola, go on, please.
I think we have to check the rules, whether we have maybe the rules that have zeros. I don't know that they are no, they are empty. That we should just start doing the cleaning of the data.
Okay, data cleaning, right?
Yes, yes.
Okay, Mr. Simon. Mr.
Yeah, so
Simeon. Okay.
okay. Yeah, so I think that before we check the null or the empty rows, we should be able to get the shape of this data set and probably describe what these columns are, if they are in floats or objects, because most of them are numeric values here. So we just need to do that.
Okay, no problem. Well, that's actually correct. So, Mopelola, before we get into checking for empty rows, we should, as Mr. Simon just mentioned, we should check for the shape of this data. Yeah, Mr. Simon, do you want to complete how we should get that done?
As penguins underscore df, you
Okay.
omitted it.
Okay, all right. I did that on
Shape.
purpose. Okay, dot shape. Is it okay like this, or what else should I add? Is there anything else I should add?
I think it's okay like that.
It's okay like this, right?
Yes, yes, sir.
Yeah. Hopefully it's okay like that. Oh, yes, it is. So what does this tell us? It tells us that we have 332 rows and 5 columns. So that means we have 332 measured penguins on this data set, and there are 5 columns under these data sets. That's fine, good to know. Now you can see we are getting more information about these data sets. Now, what else should we do next? Who wants to go? What else should we do next, please? Anyone? What else should we do next?
I think we should check the detailed information about the column.
All right. So
Maybe
how do
that
we check? How do we check now? How do we check for the detailed information?
it should be pending underscore DL dot info.
Dot if info. Yes. That's correct.
And the open braces and close braces.
Yes, that's very much correct. Penguins df dot info. Great. That was correct. So here we can see extra information about the data set. From this point, we can see that we can see the columns here, Pullman length. We can see non-null. This means that so far, given that remember we had 332 rows here. So this 332 non-null means that there are no null values. In fact, we can start seeing that there is no empty or missing values in this data set from this point. Although there are still other ways to check for missing values, but this .info are already giving us heads up that there are no missing values. And it gives us the data type of these columns. So this means that Kuhlmann length is in float data type, is in float. Kuhlmann depth also in float, same for flipper length and body mass. All four, these four are in float. Why the sex column is an object type. I must believe we know the different data types we have, or yes. Please make some reaction if we are familiar with data types. Okay, I'm only seeing 4 persons, 5 now. Okay, 6. All right, I see 6 persons and there's about 16 people on the call. Okay, for the sake of us who might not know, there are different data type formats or data types actually that some data might come in. You can find some data in integer formats, which if any of our column was to be an integer format, you see data type here, it will be int. And there is float, which we can see here. Float is another data type. There are objects, data type. Okay. Right. Yes. So, like I said, there are int data type, there's a float data type, there is object data type, and hope I'm not missing anyone. Who else remembers the other data types we might have? Does anyone remember an extra? Hopefully, I'm not missing anyone. Mopelola, you know? Yeah, who wanted to say something? Please go on. Sorry.
We have the Boolean, the true and false.
Thank you very much. Yes, we have Boolean. Yes, we do. All right, so let's get that out of the way and let's move on now. So what next? What next, please? Guys, this should be so practical. Let's get involved. What next should I do?
I think using the dot describe method to get the mean, median, percentile of the numerical data.
Okay. Penguins df dot describe. Okay. So this is what dot describe has given to us. So basically what this thing means is it's giving us some metrics for this data set. Now, it's telling us for this index, please follow my cursor. If you look at this index, the first row is count. It's telling us the count of each column. That is, for the Coleman length, there are 332 penguins. Same for Coleman depth, flipper length, and body mass. Then the next is mean. This mean is giving us the average of, because mean sometimes refer to the average, depending on if, I believe we should know this. Mean gives us the average of our data set, depending on if the data is skewed or not. I just hope I'm not sounding vague, because this is one of the basics we should know as a machine learning engineer. So mean can rightfully tell us the average length we have for this Coleman length of each of the penguins we have. So for these 332 penguins, the Coleman length, the average Coleman length is 44.021, etc. in millimeters. The same for Coleman depth. The mean length, the mean Coleman depth is 17, mean flipper length is 200, and mean body mass is 4206. Now, the standard deviation, which is the third row here, the standard deviation for the Coleman length column is 5.45 etc. For the Coleman depth, the standard deviation is 1.96. For flipper length, it is 14.03. Body mass, it is 806.36. There is. And the minimum Coleman length, that's what the fourth row is telling us now. That what is the minimum length we have for each column? Sorry, what's the minimum we have for each column? Under the Coleman length, the minimum we have is 32. Coleman depth, the minimum we have is 13.1. Flipper length is 1.72. Sorry, 172. Yes, there's no point. 172. And for body mass is 2,700. That's the minimum length. That means for the whole data set we are given, the least weighing penguin is 2,700 in grams. Please make some reaction if I'm making sense so far. Just give me a thumbs up. Thank you very much, everyone. Okay, so next, 25%, 50%, 70%. This talks about percentile. Now, what 25% means is that it means if you get these data sets, 25% of them and below have a Coleman length of 39.5. I just hope this is not confusing. For Coleman depth, it means 25% of them and below has a depth of 15.6. Flipper length, this means 25% of them and below have a flipper length of 190. And body mass, 25% of these penguins and below have a mass of 3,550. The same applies to this 50%. It means that 50% and below have a Coleman length of 44.7. Under the depth column, it means that 50% of these penguins, the Coleman depth for 50% of these penguins and below have a depth of 17.3. Flipper length as well, 50% and below have a length of 197. Same for body mass. And the same goes on for 75%. That 75% of them and below has 48.6 for their length, their Coleman length, Coleman depth, and so on. And the max Coleman length we can ever find is 59.6 on this data set. The max column depth we can find is 21.5. The max paper length we can find is 231, and the max body mass we can find is 6,300. Now, guys, we can all see how we are gathering more information. We are getting more abreast with these data sets. Like, we now know that, okay, these are some of the information about these data sets. Deborah, you raised your hand. Is there any clarification you need, or you want to say something? How can we be of help, Deborah? Hello, Deborah. I can see your hand is raised up. Unless that could be a mistake. Mopelola, I see your hand is raised up as well. Any clarification? Okay, that might be a mistake. And Deborah is not responding, so let me guess that's a mistake. All right, so let's get on with these guys. All right, so what's the next stage now? What's the next stage, please? All right, Mr. Adedeji, please, what's the next stage?
Okay, on my side, I think we are pretty much clear on preprocessing already. So we can now go ahead to import our modules for training for training. And first of all, from the describe, we'll look at the variance of the tables. Each of the columns, right? The variances are not exactly equal. For example, we are having a standard deviation of 806 for body mass, and we're having columns depth to the 1.9. We're having common length 5.4. So we want to use a standard scaler to make sure that the mean of all the columns are 0 and the standard deviation is 1, so that we'll be able to, because since for k-means we are using Euclidean distance, and any model that requires us using distances on, we will want to make sure that all of their variances are the same, so that there will not be a bias on one side of the data. One feature will not be saying more than the other. So we want to use standard scaler to make sure that each of all our features have the same variance. So we will use standard scaler, we will import standard scaler, then we'll also import k-means. We can use a pipeline, or we can do it individually. So that should be our next step.
All right, that's well detailed. Thank you very much, Deji. Ibrahim, do you have something extra for us? Do you have something extra? Please go on.
Yes, I think we skipped checking whether there were duplicates in the data set.
Okay. If they are duplicates, right?
Yes.
Okay. Anything else?
No, sir.
Okay. Anybody else? Anybody have something extra? Okay, Simeon, please go on.
We might not need duplicate, because it's possible to have penguins with the same length. So I'm wondering what duplicate will do. But I just feel that we just need to check if there are empty values, where somebody had already mentioned, but I don't think we have done. Okay, no, it's all right. It's okay. I think then we're good to go.
Okay, thank you, Ibrahim. Labibat, please go on.
I think we're meant to import get dummies, like create a dummy variable. Since the section under that sex is like male and female, I don't think computer will be able to like recognize it. So we have to like convert it from categorical variables to numerical formats.
Thank you, Labibat.
Thank
you, Labibat. Wow, we have machine learning gurus on this call. I'm impressed. Everyone input is just on the right side. I love it. So let me start treating accordingly. Before I go to Mr. Deji's and Mr. Labibat's input, let's talk about duplicates. Now, it's fine we should check duplicates for this data set. And Simeon said it might not be necessary because there are penguins, which is logical. There are penguins who might have the same measurements. But the problem with that logic is we are dealing with more than one features. So, Mr. Simeon, in a case where we have more than one feature, that we are not just dealing with column length, there's a possibility that each of these penguins, given that there are more than one column of feature characteristics, is distinct from the other. Yes, there's a situation like that each of the this thing might be distinct from the other. So it's okay we check for duplicate. Like if one entry which has the same, like for the same penguin have been logged into our data set more than once. You understand? Because now the data is sparse. Let me use that word, sparse. Sparse means that it is as distinct as it goes, given that the number of features has increased or is increasing. Please let me get a thumbs up if I'm making sense so far. All right, thank you guys. So in this situation, if we have to go on to check for duplicates, we should, given that the data have more than one feature, just in case. So who told us about duplicates? I think that should be Labibat, right? Is it Labibat? Who talked about duplicates? I can't get to remember. Mr. Ibrahim, you want to say something?
Sir, it was me that said something about duplicates.
All right, so how do we check for duplicates now?
I think we should use the name of our data frame, which is penguin underscore df. Then we use the method duplicated dot duplicated.
Okay, dot duplicated, right?
Yes.
All right, dot duplicated, and it is outputting. Do we have to go through all this to know if there's any duplicates? Who can suggest how we deal with this? To just see a summary of if there's a duplicate or not. Anybody?
Can we try dot unique?
Okay, who is that, please? Somebody
Simeon.
just said dot unique.
Simeon.
Okay, yes. So dot unique, right? That's your suggestion. Yes. Okay, let's see dot unique. Let me comment out all this so I don't have a long output. All right, let's try Simeon's suggestion. So Simeon, you say we should do what? Dot.
No, I mean after duplicate.
Okay.
After duplicated, rather, we can just extend with dot.
Okay, unique. Okay. Dot unique, right?
Yeah. Dot unique or distinct. Oh, yeah. Let's try dot unique.
Dot unique. All right. Array false. Well, not as detailed, but yeah, you want to say something, Simeon?
No. I feel it's okay. I don't have any other thing.
You don't have any other thing. Okay.
Hello, sir.
Anybody else?
Hello, sir.
Yeah, Hakim, I'm with you.
What about using the dot sum after the duplicated?
All right, let's try that then. Beautiful. I think this is better. We could use .unique as Simeon added, but .sum helps us summarize the number of duplicates we have. So in this case, there are just 0 duplicates, meaning no duplicates at all. All right, so thank you very much so far, guys. I like the activities we've been putting in. So let's just move on now. For the next, what's this? Okay, I'll create a new cell for the next phase. Here I will now call on Mr. Adedeji's and Mr. Labibat's input. So someone talked about get dummies, and someone else talked about, I don't know which of them talked about going on to scale and train the model. But in an order of ranking, we should go first. Between scaling and what's it called? Getting dummies, we should go first. Which should we attack first, guys?
Getting dummies.
Who was that, please? Someone just said something. Samuel, was that you?
Yeah, I said getting dummies, but I think I made a mistake. I didn't raise my hand, so that's why I'm quiet.
Okay, so why do you say get dummies? We have to be intentional. We have to reason. We need to have a reason for why this first, why this next.
Yeah, because I feel that if we're already getting the model activated, we should the data should be in the right format first.
Okay, before we scale, right? Before we standardly scale.
Yes.
All right,
That's
Mr. Deji. Okay, thank you, Mr. Samuel. Mr. Deji, how about you?
I'm kind of skeptical about us using the sex feature for like turning them, making a 1 or 2 encoder, getting dummies. But I just want to know what significance is it going to be when we train our data, because I thought it's only the length, the length of the wings and the flippers and everything that will be able to tell us what species of penguins it is. But because on my own, when I did it, I dropped the sex column because I thought it was not going to be needed. So, but why are we exactly using that? Why are we exactly categorizing that?
I love that. I love that input. That's a very logical thinking. Who can attempt the answer to that question? So I'll summarize what Mr. Deji said in case we didn't hear him. He said that what significance does this column sex holds in order to cluster this to be able to meet our end goal? Like, what's the use? Why can't we just drop them? Since he's assuming that it's only the length, depth, and flipper length, body mass that should be very vital for us to reach our cluster goal. Who can answer that question for us? Anybody want to try?
Let me say something that for me it might a little contradict Deji's point, but then I think he is correct. But my point for me, why I feel sex should be part of it, is that it's possible from the insight we will get at the end, we'll discover that maybe one particular set are just majorly male, or another part is just majorly female. That's my thought. That's why I feel that set should not be completely removed at this stage.
Okay, it's majorly okay. You say that at the end of the day, we might have to, or we'll find that.
Yes.
Okay. We'll find a segregation between male and female.
Yes, based on this body mass.
Okay, based on body mass, right? Okay. I like that. Thank you, Samuel. Okay, Akachi, please go on.
Hi. So I don't know about this particular data set, but when it comes to animal species, sometimes some characteristics in some species can cut across gender. For example,
Okay.
in animals like goats. So
Okay.
for some species, once you see a beard, you assume that that is a male goat. For some other species, both
Mm.
male and female of
Mm.
the goats have beards. So you might have a situation where
Mm.
for a lot of species, the flipper length is within a particular range for males and is shorter
Mm.
for females. And then you
Okay.
end up having species where what you generally consider a male flipper length applies to the female of that particular species. So I think for the data generally, it may not be advisable to just assume or generalize. Maybe check the correlation and then drop things that have high correlations instead of just assuming that it will not have an effect on the clustering.
Okay. 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 I get you. That's true. All right. Thank you, Akachi. Hikma, please, what's your input?
So I feel the sex data set is important because sometimes we end up having some animals that are of different sex, but maybe they have other features the same. So the only difference is that this is a male and this is a female. But the body mass, the colon length and width and the other things are all the same.
Please take that again. I didn't get you.
So I said I feel like the sex is important because sometimes animals tend to have the same mass, length, every other parts of the data set. This our data set is the
Mm.
same, but the only thing that differentiates them is their sex.
Okay. Okay. I get you now. Thank you. Someone asked in the chat, what's the question? Okay. I can see a response, whether the sex. Okay. Okay. Thank you, Ibrahim. So, Odimayo, you asked what the question is. Now that you get it, what do you have for us, Odimayo? I can see your interest in the question. I like that. So, what do you have for us? Or you still need more clarity on the question? All right, there's no response from Odimayo. Now, for this question, this particular question, overall, one of the things we should have in mind before we answer this question is, at the end of the day, is there a situation where we have to deal with sex as a goal, like the sex of these penguins? Like, and these are our questions. Remember the questions we are working with. For these questions now, there's no place where they say, okay, do this by sex, or let's get an input or insight about what sex hold this, or which of the sex is more than the other. But another question is this sex feature really that important for a case of what's it called, clustering? Because if it was for a predictive model, let's say like a linear regression or this thing, or what's it called, yes, a prediction, a classification situation, sex is not something you should just throw away, because there are certain situations where um, sex in it could hold a very powerful importance. But for a case of clustering, in a clustering algorithm, is sex really that important? Now, it depends. It depends. There are situations where sex is important for clustering, and there are situations where sex is not important for clustering. And I will tell us. Now, let's take a medical data for instance. And let's say you want to detect, you want to cluster, you have the medical data now, for instance, and you're clustering patients in this situation to detect, let's say you're detecting a heart disease. And in the data set you're provided with, there are males and there are females, that is the sex column for male and female. Do you think they will have different symptoms or risk? If you agree, just give me a thumbs up. Okay, Hikma agrees that they will have different symptoms and risk. Okay, 2 persons so far. So that means the rest of us is saying they won't have the same, or they won't have different symptoms or risk factors, right? Odimayo has answered through the chat. Okay, I hear you. All right, but for given this same question I'm asking now, for a medical data where you're clustering patients to detect heart disease, for instance, and you have a male and female column, do you think this holds significance when you're clustering? Because it's through this now, if you can answer this set of questions, I think it will take us closer to the answer for this situation. I want to paint 2 scenarios. I'll paint one with medical data and I'll paint with another. Okay, only Hikma and the other person agrees that they will have different symptoms of risk factors. Now, the next question I have concerning sex, if it's an important feature, is let's say you're clustering for, you have a goal for customer segmentation. Customer segmentation means you're dividing this, given the data set, you're clustering the data set into different sets of customers, giving different features. Now, if you're detecting buying patterns, because if this customer are segmented by their buying pattern, do you think that some of these features, let's say their income and preference, will be dependent on sex? And if it will mislead the clusters, please, I want someone to just come up and let's hear their input or their answer to this question. Because with this now, we can be able to answer this particular question that we have at hand. Please raise your hand if you want to try out this question we have at hand concerning the customer segmentation. Anyone? Or is it that we are not understanding the example I'm trying to paint? Please, if you need more clarity, let me know. We are so quiet. Olujoseph, please, can you get on the mic? Let's hear from you. I like your input so far. All right, Mr. Deji, let's hear from you.
Okay, so for the customer segmentation, right? For example, let me say that like a big mall wants segment customers based on their spending habits, for not to lean on stereotypes, but you know that like the women will maybe want to buy more fashion products, more cosmetics products and everything. So they will like look at the gender to be able to segment. Okay, maybe the men like to buy gaming items, or maybe they want to buy, but the women will maybe want to buy fashion or cosmetics or grooming products. So knowing the demographic or knowing the customer behavior of a particular customer based on their sex would help you to segment for customer demographics.
All right, thank you very much. All right, Olujoseph, please go on.
Okay, so I put there it depends on the business and products. For example, if you sell fashion, cosmetics, personal care, so gender can be highly predictive of the purchase behavior. If you sell groceries, utilities, and maybe tech gadgets, gender may not matter as much as other factors like income, family size, and like that. But gender too, in the other case, might interact with other variables. So, but generally, from what I know in segmentation, the best practices usually will be that you should first use what we call behavioral feature first. As purchase frequency, the recency bias, or what do they call it? The spending and product mix, like that. Then we can now use demographics like the sex, age, location as the second to interpret and label the clusters after they are already formed. So that's the way I see it, and that's the way I understand it. Yeah. Thank you.
All right. Thank you, Olujoseph. I like that. I like everyone's input. Now, especially the question. I like the question Mr. Adedeji raised up. Like, it's very much important because at the end of the day, there are certain features that are not really necessary to get on with for this for our model to train on, because they could just end up being noise or not important at the end of the day. So the question is very logical, and I like how we engage logical for it. We are right if you mentioned that at the end of the day, these data sets, like some of these penguins could have, like the female version of this penguin should have slightly different features than the males. You're very much correct, because we can see that in animals for the situation like, yes, where we have some animal kingdom, we find the females more larger in certain features or characteristics than the male, or the male having certain characteristics different from the female. The female, yes. So that reasoning is actually correct. But for this situation, and given the end goal, the sex is not really that important to work with. But we can go ahead with some further steps that we are doing for other features for this sex column. Now, I'll give you a situation where this sex would have been very, very much considerably important. Now, if our end goal was to split these clusters into male or female, instead of just structure, then it's okay that way, to just pass on the sex to the model to train. And the other situation is, now this clustering, for instance, now does not, the end goal doesn't in any way demand that we have to cluster with sex in mind, because all we need in terms of features for the other features now, it's already there. They're already there. The length, the depth, all those measurements are already there. But if the goal, the end goal, it depends on the task. If the task wants us to make sure that these splits have sex in mind, then we can go on to add it. But at this stage, by default, it's not that necessary to include the sex. We could go ahead to drop as Mr. Deji suggested, but we won't drop at this stage, and I'll tell us why when we go on. So we put that, we having that in mind, the next thing we have to do is we can get dummies. Yes, because if we are not dropping them, why? If we are not dropping them, why get the dummies? Oh, sorry, if we are not working with sex, then why still get dummies? I'm still going to answer that. But before that, who can tell me how to get dummies for these data sets and why we even Okay, let the person also explain the logic behind getting dummies. Anybody here want to try? How to get dummies? That's just the question. And the logic behind it is a very simple one. Okay, thank you, Adebayo. Please go on.
Okay, good evening, everybody. Okay, so I think you use pd dot get dummies to get the dummies. I don't know the words in but it's pd dot get dummies in this.
Okay, you don't know how the code goes, right?
Yes, I know that you use the dot get dummies
Okay.
function now. Yes.
Okay.
Yes.
I might have cleaned that something. Okay. So we can name it as penguins dummies pd dot get dummies. Penguins df. All right. Data count seems to be a very bit slow. What's going on? Maybe I have to restart this page. Let me reload the page. All right. Should be doing this in the next cell, not clogging everything in one cell. All right. All right. Load this page first. From this. Is this just data camp or what's going on? Oh, yeah. I'm missing out something. I didn't. Sorry, guys. I didn't print this out. Okay, so PD dummies. This was a mistake. All right. This should work. So the reason why I still want to call these get dummies on this data is there's something I was explaining from last class. I don't know who can remember. I made an explanation and I used dummy variable, used dummy as part of the explanation. I don't know who can remember that. That's what I want to explain using this practical situation. And if you can see from this observation, initially, if you can look from this explanation, initially, let me call dot head. Yeah, dot head. Okay, if you look from here now, you see that this sex column was just one, right? It's just one here. We just have one column for sex. But after getting dummies, we see two different columns from what we had last time from the initial data set. You can see here. This is the result of calling these get dummies, which is a situation where you just encode, it just attributes codes to the values under that sex column. So what happened under the hood is, for the male, for the first column, two data set was set up, sex female, sex male, like for all of them. Now, if this row was a male, the sex female here, the sex female column here is why we have 0, means no. Why sex male is 1? Because yes, that row is for a male. The next row was a female. That's why you have 1 here, and it's not a male. I hope you are understanding this. Please give me some thumbs up if you understand what I mean. All right. But now, there's something I explained last time, and I'll remind us. I talked about there are situations where you pre-process data, like this is part of pre-processing, data pre-processing, and you end up having more features. Like there are a lot of features in this case. And one of those concepts is when you try to encode, especially using get dummies. And you can see now, we had just 5 features initially, or 5 columns, 1, 2, 3, 4, 5. Now what do we have? 1, 2, 3, 4, 5, 6. It's increasing. And for certain models like K-means and what's it called? KNN, that doesn't do well with high dimensional data. Situations like this can just lead you off the road. Like it can put you into danger, which we remember I mentioned the cost of dimensionality. Can we all remember all this from last class? Please, thumbs up if you remember all this. Only Enoch remembers. Okay, Ibrahim, Hikma. All right, thank you very much, guys. So this is a situation, a practical situation from what I was explaining last week. So now, going further, what should we do next now? What should be done next? I believe we were thinking what should go first between. Okay, Mr. Deji, you can go on.
We can now do the fit transform of our k-means on the model. That would be better. Wait, okay, yeah, okay. First of all, okay, since we are not dropping any columns, so we can just fit transform our k-means. Then after that, I think we'll now find how we can make optimal clusters. Hello.
Okay, that's fine. That's very much true. So we have to standard scale, right?
Yes. We'll have to do that. We'll standard scale first.
So how do we do that? How do we do that now?
Okay, we'll initialize the standard scalar. We can say, since we already imported it, we can just use any variable. Let's just call it scalar. We can say scalar equals to the model standard scalar brackets. So then we'll now fit transform
equals to the standard scalar. Okay.
Yes. So
like this, right?
So yes, like that.
So we go ahead.
So that's now
what next?
Fit transform. We now fit transform the scale on data.
All right. We can name that as penguin scale because we're actually scaling right now. So that will be scalar, right? Dot fit transform.
Fit underscore transform. Yes.
Fit transform. Yes. Then what are we transforming?
Our penguins underscore df. Okay. Yeah. Okay. Oh no, sorry. Penguins underscore dummies. Yes. Penguins underscore dummies. Yes.
Okay. Penguin underscore dummies. All right. Just hopefully that we might not know about this for some of us. Now, if you observe, we are passing the full data frame in this situation to get dummies, because if get dummies is meant for, because the logic for getting dummies is to encode categorical or object via columns. Now, why not just pass the object columns? It's because get dummies on its own have been structured. This method have been structured to just look out for object columns. That's why you just focus on this. If you look now, the numerical columns were not, or floats or integer columns were not touched. It's only the categorical column, which is sex plus touch. So I just want us to have that at the back of our mind as well. All right, so we are done scaling. Let's see what our scale will look like. But first, what is this scaling like? What's the logic behind scaling? Why are we even scaling in the first place? Although I think Deji touched on that so much, but I still want to hear an extra or maybe a complementing explanation to this. Why are we scaling? Because there should be a reason for everything we do. Please, who have an input, just kindly raise up your hand so that we can move fast and hopefully finish before 8 o'clock. Anyone, please? And we also have an error here. Penguin dummies is not defined. Okay. I think
there's no S in that penguins.
All right. Thank you very much. I appreciate there's no S. That's very much true. Okay. Yeah, this works fine now. All right. So anybody wants to talk about standardization? Because that's what we just did now. Okay. Please go on, Olujoseph.
Okay, in summary, clustering is usually, or should I say k-means clustering is usually distance-based, and features with larger range will dominate if we do not scale. So scaling basically levels the playing field. There is no, oh, this one gets more, this one gets lower. So every features in that data set will likely contribute fairly to the cluster formation. Yeah.
I like that. All right, Samuel, do you have anything else to add?
Okay, good evening. I think he's exactly what he wanted to say. What he said is what I wanted to say. The only thing is I can contribute is that if it's also about range. So if there are situations whereby maybe there are some that act like outliers, it may cushion the effect of the outliers, especially when you bring it to the. That's my input.
Okay.
Thank you.
Yes. All right, I appreciate your input. Mr. Deji did well, Mr. Olujoseph did well, and Samuel as well have done well. But now I want to add something, because this is one of the basics we should have at the tip of our hands as a machine learning engineer. Guys, this is one of the basics we should know. Standard scaling is something you should look up to in most situations, because like Olujoseph put it levels the playground. Like, we don't want our model, like 3 of them have already added in summary, we don't want our model to start focusing on one feature or than the other. Like, for instance, now, given these 4 features or 5, Kuhlman length, Kuhlman depth, flipper length, body mass, we don't want a situation where the model tends to focus on one particular column, because if the size of values in this particular column tends to be higher than the other, so the model starts assuming that since the values here are very high, it means this feature is very important to. That means if I want to predict, I will always have to put this body mass first, because if you remember, I think describe gave us that. Let me uncomment describe and show us. Yes, Like if we see now, the max value is here. You can see for Kuhlmann length, the max value there is 59. That for Kuhlmann depth is 21. Flipper length is 231. And the max body mass we see here is 6,300. Well, that's so much. And if we were to pass this just like that, you see that the model will tend to favor more of this feature, this body mass feature, as one of its criteria to cluster this data set or these penguins, and that would be so unfair for the other features. So that's why standard scaling is employed. Now, what standard scaling does under the hood is it helps them it helps bring all features to a single point. This single point is they are having a mean of 0 and a standard deviation of 1. So what that means is if you were to calculate single-handedly, if you were to try to calculate each feature, let's say we go for Kuhlmann length now. Yes, for the whole of this length now, this Kuhlmann length now that I highlighted, if we were to calculate the mean and the standard deviation of this particular feature, for this one now, after it has been scaled, you find that it is 0. You find that the mean is 0 and the standard deviation will equal 1. And if you look at these values now, you see that you can't find high values like 8,600, 2,000, 4,000 like we were seeing. You see how leveled they have been brought under. This is to help the model perfectly distribute importance among these features. Please, everyone, thumbs up if we are following along so far. Just thumbs up, please, if you understand so far. All right, thank you very much. All right, so who can tell us what next we need to do from here? Like after scaling, we've seen our scale. What next do we need to do? Anybody? All right, Akati, please go on.
Sorry, please, I have a question.
Please go on, please.
So, I think I saw this somewhere. I want to find out if it's standard practice. So, for a case where we have, like what we have for the sex that we created, we have male and we have female.
All right.
So, let's say is feature selection, so to speak.
Okay.
In case of these animals, I think it stands to reason that one cannot be male and female at the same time. So if it's male, we already know it's not female, and if it's not female, we know it's male. So in that case, it's possible to drop one of those features. You can drop the dummy female and just use male, or drop dummy male and use female. So if it's not this, it's the other, since they have a -1 condition. So my question is standard practice, or is it better to just still train your model with all of the features intact?
Oh, wow. Thank you very much for bringing that to attention. I like that. And that's very much correct. Now, guys, let me summarize what Akachi just mentioned. You know, there are situations where after doing get dummies, like we did here, like if we're moving on with getting dummies, like we're moving on with the object, after doing get dummies here, we find out that the two outcomes here tend to be like you mentioned, like, of course, if this sex is female, and that means if the sex situation here for this particular penguin is not female, therefore the male should be the one for male should be yes, which is 1, and that is very much true. So now the question Akachi is asking is it standard practice? Because yes, there are situations where it's advisable you have to drop one of these columns as a standard practice. So the question now, I want to throw it to everyone. Should we go back and do this? Do we agree that this is something we should do? Anyone? Or does that idea sound so new to us? Okay, so the question is, Akachi made an observation for us that there's a standard practice that says if you're using get dummies, you have to drop one newly created column. Now, when you run get dummies, you see we have two newly created columns for us. But there's a standard practice that says we have to drop one column. So the question is, should we go ahead to do so?
Sorry, I wanted to ask, why exactly is that practice? Why exactly are we doing that? Is it because of maybe there's like multicollinearity? Are they like collinear, or there's like a correlation between them? That's why we're dropping one, or is it because one is redundant, or why is the reason?
Yes, and you've answered the question. There tends to be multicollinearity if you want to keep them. Can you hear me, Deji?
Yes, I can hear you. Okay, yeah, that clears the air. Thank you.
Yes. Anybody else? Unless I would assume we are agreeing that we have to drop one of the columns. Okay, no problem. So Akachi,
okay. I think we should not drop it, because I think the thing that one alt encoding does is that, for example, maybe if you are encoding male as 1 and female as 2, the algorithm tends to feel like, okay, maybe male has more importance than female. Maybe male, because male is 2 and female is 1, then it tends to maybe give male more importance. But because when we are separating them into female and male, in a place where the female is 0, the male will 1, place where, so there is no, like, both of them are more balanced. So it's not really putting more priority to one class than the other. So I feel like if you remove one column, it removes the importance of one not encoding. That's what one not encoding tries to do it. So it doesn't give one class more importance, because if one is 1 and one is 2 and one is 3. So I think we should leave it.
Okay, so we shouldn't drop one column. We shouldn't drop either the sex.
Yes, we should leave it.
Yes, because you're following along. The two columns we have here now is one is named sex female, one is named sex male. So these are the two columns we are thinking if we should drop or not. Any of them, should we drop any of them or not?
No. We should not drop. If we are using, we should use both of them, or we are dropping both. I've not heard of a case. Maybe I might be wrong, where we one not encoded and we drop some columns and we leave just one of them. I don't think. I might be wrong, but if we are leaving one of them, we should just use both of them, or we should drop both.
We can drop both if we decide not to do with the sex column. Initially, like I mentioned, it's not really that important in this situation, but I want to include this because at the end of the day, we find that it doesn't really hold. We'll see that at the end of our operation, and we'll get to answer that. But for this situation, there's something called dummy variable trap. And our advice, we look that up. Mr. Deji, advise you look this up later. There's something called dummy variable trap. Now, this trap says that if you're running get dummies on a particular data set, you tend to end up with a lot of features that's noted. But now you have to drop one because they're almost the same in terms of they are multicollinear in this situation. That's why you have to drop one. You don't have to keep all the columns that have been generated, because you end up with having columns that just resemble each other and they don't really make sense, because the machine can be able to make sense of this, that okay, for this column, since if we drop one now, let's say we drop sex male now, and it sees that, oh, sex female is 0, of course the machine will know that this is not a female, it is something else, which is a male. If it comes to the next column, I see that this is a female, fine, this is a female, that goes on, and that's it. I don't know if you understand, Mr. Deji.
Yes, I do now. I do. Thank you very much. Okay. Yeah, that makes sense now. Thank you.
Yeah. Okay. All right. So okay, so how do we go on, please, guys? We are almost out of time so that we can get to the finish line. What next should we do from here after scaling? Anybody, please, quickly. We split the data. Okay, Mr. Samuel, why do we split the data? Why do you think we should split the data? Oh, yeah, and we just talked about dropping the column, and I didn't execute that. A lot of things going on in my head at the same time. So, Mr. Samuel, before you go on, this is how we, if I remember correctly, yes, this is how we drop one of the columns. We use drop first, and that should be a Boolean. Drop first equals to, yeah, that should be true. Let me see. All right. So he dropped the female. You can see, guys, you can see here that we just have sex male. All right, so that's executed. Let me rerun this scale to update. All right. So Mr. Samuel, you can go on now.
Okay. I'm so sorry. I don't have any tangible reason why I say we should split data. I just feel like if you are going to, the next step now after scaling is to split the data so that it can go into the model. That's okay, sorry.
Okay. Okay. I thought you wanted to add something. Well, anybody else? Do anybody agree that we should split the data or not? No, I don't want Mr. Adedeji, not you, Mr. Adedeji. Hakim, say something. Deborah, say something. And somewhere it's okay. Like I like the question, I like the suggestion. Like I want us to walk through the reason why we should do this and why we shouldn't do it, why it is necessary, because these are the thought process you should have whenever you're working with a data set. This thought process guides you to actually deliver a very good job. You understand? So even if it comes to your mind that split the data, you should be able to tell yourself, okay, why shouldn't I split the data? Why should I split the data? So that's what I want us to address now. Mr.
Good
I
evening,
haven't
sir.
heard from you. All right, Akima, go on, please, go on.
We can't split the data because we don't have a dependent or independent variable. This is an unlabeled data that we are trying to cluster.
Okay, that's very much fine. Labibat, are you trying to say something too?
Yes, sir. I
Okay,
think
good one.
the next thing we should do is like use the k-means, like perform a cluster analysis.
Okay.
Something like that.
All right, that's fine. All right, so yes, we don't have to split the data as Akima mentioned. And in addition to that reason, this is unsupervised learning, and somewhere we don't have to do that because there's no labeled yes, the data is not labeled and we don't have anything to validate our train on. I don't know if that makes sense. So, for a supervised learning, you split the data into train and test. Now, you use the train data set to train the model, and you use test to test if what has been trained on is correct. And remember, these data sets are labeled to tell us that, oh, this is true. This particular prediction is made compared to the test data, confirming from the test data, is it true? I believe I'm making sense. Okay, yes, that's true. So splitting the data at this point, it's not necessary because this is it's unsupervised. We just have to get on with clustering if we've gotten to that point instead of splitting. But before that, there's something I want us to do. This data now is in an array format, and we'll get to see that. We can get on to work with this array format, but let me see if I can do something with this penguin scale. Let me call .head on this and see if we can visualize what this look like. Like, let's see if we want to get our data set like this. Like for column length, let's see how the scale values look like, column depth, flipper length, body mass, and the sex. But this throws an error. Now, why? This is because what we have here after scaling is a NumPy array. And NumPy array doesn't have this .head feature or function like a data frame. It's only a data frame you can call .head on. So what do? Let's convert this to a data frame. This penguin scaled outcome, let's convert it to a data frame in order to visualize it as a data frame. So how do we do that now? I'm going to name that penguins scaled DF, and to get that as a data frame, I pass in the penguin scaled, and I have to name the columns because, okay, let me do this without the columns so that I can carry everyone along. All right, let me call penguins scaled data frame dot head. Okay, I misspelled this. Scale. All right, this should be better now. All right. Now you can see we can be able to call .head on this to visualize how each standardized values look for each of the features. And if you see now, we've lost the names of our features. Like, you see here is 0, 1, because by default, since we didn't give names to each columns, the pandas library just automatically attributes this 0, 1. But if we want to recover the names of those columns, we can impute those columns here. Impute that using the column value in this data frame method. And what are those columns? We can access those columns with penguins. Yeah, I think that should be dummies dot columns. But there might be a bit of a problem. Let me confirm that first. Let me show us what penguins dummies the columns. That's what I was supposed to do earlier, not underscore columns. All right, let's see what that outputs first. Guys, as you can see, we have the columns names. So this is what I just want to show us what this looks like under the hood so that we don't get confused why I pass it into the columns. Fine. Let's go ahead. And let's call penguin scale data frame dot head. Beautiful. The names of our columns are back, right? We can see this. So now you can see the standardized values under each column. So now let's get going. What should we do next? We are working with k-means for clustering, but what should we do next? We are close to the finish line, guys. Just hold on a little. Anyone, please quickly, what should we do next? In fact, I know we should train the model, but all right, Mr. Deji, go on.
Okay, so first of all, we need to revisit the question. We're not specifically giving a number of clusters to use. They just told us to perform a cluster analysis, but we can now use the elbow method to maybe find our optimal number of clusters. And by that, we, the inertias that we use, we can make a range, right? Like a cluster range. And the cluster range, so the cluster range can mean maybe within 1 to 10, then 1 to 10. So we'll now make a loop. We can say, okay, for K in cluster range, then we'll now fit our K-means on our data set. So the n clusters will just be K. So it will run through our range, then we'll now plot our elbow model. So the one where there's a sharp, decline in the inertia, since we are passing, our inertia to our lists, right? I think there's a list. Yes, that's how I did mine. So we'll now pass it, then we'll now plot it. So that is the number of clusters that we will use that is optimal, since it's not too underfitted and it's not too overfitted. It's just right in the middle. Makes it optimal.
Yeah, I like that. That's beautiful. That's beautiful. All right, please, a round of applause for Deji, please. Everyone, appreciate him. Thank you very much. Thank you very much. Yeah, so that's the road we have to take. Now, if we remember last week, I don't know how many of us were in class last week when we talked about k-means and the setback of it. Like the setback is the setback for a k-means clustering algorithm. This k-means clustering algorithm is, yes, this particular one that we are importing from I think scikit-learn in this situation. This particular algorithm has a setback, which is we always have to initialize the number of clusters. Now the bigger question is, what if the number of clusters we are initializing is incorrect? What if the optimal number of clusters that the data set should achieve is more than what we imagine or we are guessing it to be? You understand? I will get to see that shortly. We'll see where we initialize the number of clusters. So now let's get on with Deji's suggestion, which I actually vote for too. So to do that, we have to initialize. We have to choose. First of all, we have to choose a range. In this situation, we have to choose a range of number of clusters we have to pass to the model. Now we can say between 1 and 10. Oh, okay, let me do this by default. Let me cite a situation where we don't have to do that elbow method. Let me call that k-means model and initialize k-means. Initialize k-means, and the primary things we should pass is number of clusters, which I just explained. One of the setbacks that this algorithm has. Number of clusters is equals to, let me do the guessing now. Tumbo. I'll pick 6. All right, 6. You can see I'm guessing, guys. Next, I have to include a random state, and I will explain this. I will explain this shortly. Let me take a random state of, let's say, 42. And Let me fit this. Okay, no, I'll fit later, but let me explain at this stage. Now, guys, you can see that I get to just guess, like I'm guessing, and it shouldn't be so. What if this data set deserve the optimal number of clusters we should attain for this data set is less than 6 or greater than 6? You can see how where the setback of k-means clustering is, and that's why we have to employ what's called the elbow method. That's why we have to employ something called the elbow method. Now, the elbow method helps us determine the optimal, as Deji puts it, the optimal number of clusters we should use for this clustering. You understand? So I will comment this out and let's go on to do this. So now, this situation where I was saying range of 1 to 10, this indicates the number of clusters we want to train the model on, the k-means model on, and we'll see that. Now, for those of us that are confused that what does this range 1 to 10 output, I'll show us now. Let me print that out. Oh, sorry about that. That should be, I think I don't have to even call on print. Or do I have to call on print? Trying to get how this should output. Don't want range. I don't seem to remember how to output this value, but under the hood, what happens is when we run a for loop for this is what we'll get. We'll get a list that outputs like this. Seven, 8, 9, and 10. Yes, this is what we'll get. And let me show us using a for loop. Now, this is how a for loop will look like. For k in range 1 to 10. Now, for this range, this is what I need, so I'll just copy it. And instead of passing 6 in here, I will pass k for this number of clusters. Instead of passing 6, as I guessed, I'll have to pass k. Now, what k does is, k is substituting for each values that is run in this range. So that means when this for loop run at first, it is 1. It will pass 1 here into this k. When it comes back again, after running that, it will pass 2 inside, it will pass 3, it will pass 4, like that, until it passes to the end of it, which is 10. Let me comment this out. I'll take this out as well. So meanwhile, there's something of interest we need while we are passing the number of clusters in order to run our elbow method. We need to capture the initial for each number of cluster. And how do we do that? We do that by accessing the initial attributes. The inertial attribute that is available whenever a k-means model. Oh, no. There's something we need to do. Sorry, guys. We have to fit that scale data set. What's it called? Penguin scaled. Let me just copy. Yes. These guys, don't be like me. Don't forget to fit your model. All right. So now we have to access the inertia that have been created. But how do we capture this inertia? Because at the end of the day, we want to plot a graph for all the inertia. So we need to find a way to capture each inertia that will be produced. So what this means is for k equals to 1, remember, this range is trying to run each of these values. That's what that range is doing. It wants to run 1. It will come in here, look for k, put in 1 inside this number of clusters, fit it, and get its inertia. Let me close this and close this. Okay. Let me initialize this. Now, this empty list box is to help us capture every inertia. That's why we append it. Appending means when you're done fitting, after including the first one for the first k, which is the number of cluster equals to 1, after you're fitting it, get the inertia when the number of cluster is 1 and put it into here. Put it inside this box, this inertia. That's what this append is doing. It's appending to this initialized list that we have here. Then the for loop will come again after it is done with k equals to 1. It will come back now. K, what's the next one? K equals to 2. It will replace number of clusters equals to 2, fit it, get the inertia, append it to here. It will run the same thing for 3, run the same thing for 4, 5, and so on until it is 10. So now, let's print out what that looks like. Let's print out that inertia and see what it looks like. I'm going to take this off. But before I go on, please, is there any question? Does anyone have any question? And you can make a reaction, please, if you're getting what is that I've explaining so far. I just hope this is not confusing or it's too vague to capture. I can see only Mr. Ibrahim understands. That means the rest of us doesn't. Please, if you don't understand, all have been okay. Thank you, Hikma. Who else understands and who doesn't? If you have a question or you don't understand, please raise your hand and I will go through the explanation again. Only 3 people: Labibat, Hikma, and just 3 of us. Okay, so now give me a reaction if what I've been explaining you don't seem to understand. Just react with a thumbs up. Thumbs up if you don't understand all I've explained so far. If there is any situation I still have to touch, everyone is mute. Okay, so I think we all understand. So now let's print this and see what inertia gets us. What that empty list now will have put. Okay, there's an error. K means is not defined. Okay, where do we have this error? K means, all right. Means is supposed to be a capital letter M. Let me correct that right away. All right, so instead of K means, it has to be a capital. I think that solves it. Let's run this again. All right, there you go, guys. You can see we have a list of inertias. Now, this 1659.999999 means that when we initialize, when the number of clusters or the model was trained on one number of clusters, like when we initialize the number of clusters to be 1, the inertia is 1659. When the number of clusters is 2, the inertia is 881. When it's 3, it's 576. When it's 4, it's 383. When it's 5, it's this 6, 7, 8, 9, 10, and on. As we can see here. So, okay, I can see 9 here. So Yes, that is very much true. Range, when you run a range like this, it tends to skip the last variable here. It tends to skip the last input. That's why we have 9 outputs here. If we count 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. So that's why we have 9 here. When the computer looks this and say it will generate a range between 1 until the value before what is indicated here. So that means if we had 11 here, we will have 10. We have the range of 1 to 10. Let me run that and you see that. You see that right away. Fine. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's how this snippet works. Let's stick to 10 we were using initially. I just wanted to correct that after noticing it. So now we have a list of our inertias captured using this inertia variable, which we've visualized. So what next will we do? Let's go on to plot our elbow method that we just generated, and I don't want to take some time on that ask directly, but let me just go directly. So to do that, we have to use our PLT, which is from Maths plots library. We call dot plots and we pass in our range. Yes, that has to go first. We pass in our range for, that's the X, or we can call this the number of clusters because this is the number of clusters we are initializing here rather. And on the Y variable, we pass our inertia. That is all the inertias we've captured for each of the number of clusters. We pass them here. And what next? Let me copy lt.show. And let's visualize what we have. Okay, we are close to the finish line, but we have to add certain features so that this can be more explanatory. Let's add a marker. A marker will indicate where each point lies, like for each of these data points where they lies. So let's use X and see how that works. Okay, this is coming out where gradually X seems off because this line crossing it. Okay, let me try O. Let's use O and see if that's more better. Okay, this is more standard. This is more standard. So guys, this is the elbow method, but to make this more explanatory, let's add some label. Let me add an X label. That means for the X side, let's add the label. And remember, this is our X label and this is the number of clusters. So we can call that number of clusters. Let's check to see if that goes well. Fine. Yes, this is beautiful. We do the same thing for Y variable. And on the Y variable, or Y axis rather, for the Y axis, which is called Y label, what we are passing through is the inertia. So we can just call that inertia. What am I getting wrong? Okay, I didn't start that with Y. Beautiful. So you can see, guys, we have our axis labeled. Y-axis is labeled inertia. X-axis is labeled number of clusters. We can as well add the title, but we can do that using the title, like to title the whole plot, just in case someone is looking at your code or your implementation, they are able to tell what this is doing and what this means. So We can call this elbow, either elbow method or elbow pattern, however you wish to call it. So fine, we can see we have the general title, yes, or whatever I clicked. Don't upload anything, please. All right, so this is our label method. And if you can remember from our last class, we use this to indicate or get the optimal number of clusters. And I want someone to tell me, from the look of this, what's the optimal number of clusters we should use? And how do we determine it? Please, quickly, we're out of time. We're hoping to close by 8. We are already at the finish line though. After this stage, I think the next thing we need to do is quite a few. Anyone please indicate if you know how to determine the optimal number of cluster to be used. All right, go on, please. Just go on. Speak.
It is where the elbow, like where the curve is becoming slow. So from 4, you notice that the curve now is getting slow. So the slope has reduced.
Okay, that's fine. Anyone else? Anyone? Okay, go on. And that's correct. That's correct. So from that idea now, someone raised. All right, Mr. Adedeji, go on, please.
Okay, so
Mr. Adedeji, you can go on.
I don't know. It's a bit dicey. What if I use 3
Okay.
or 4? What is the value? Okay, 3. It looked like it was nose diving down to like.
Okay.
Or
3 or 4, right?
Is there like? Yeah.
Okay, so you think 3 or 4, all right? Because at 3, it looks like it starts stopping at 3, or it also looks like it starts stopping at 4 as well. Is that why you say it's dicey, Mr. Deji?
Yes. Because like the loss between 3 and 4 is far greater than 4 and 5. That's why I picked 3.
Okay, that's true. That's very much true, and that's a very nice observation. Who else wants to say something concerning this? Salim. Okay. Salim, no problem, noted. Okay. Who else wants to say something? All right, no one. For the sake of time, let me just get on and speak about it. So, guys, actually, we can get on to use 3 and we can use 4. You get? Because they tend to slope at almost, they tend to introduce the slope at their points. 3 introduce a slope and 4 as well. We can use 3 or 4. Now, how we pick 3 or 4 depends. Sometimes depends on the end goal. I always encourage us to have the end goal in mind. Like if we were to deal with a customer segmentation, for instance, and you have an instruction, they say we want you to cluster these our customers into not more than 3. Let's say that was the business instruction. That's where we can able to say, okay, since the number of optimal clusters here is 3, and then fine, we go with 3. Then what if the business question or the instruction was, we want at least more than 3? That's where we get to use 4. I don't know if I'm making sense. Please make some reaction if we are making sense, if I'm making sense so far. Because at the end of the day, as a machine learning engineer or a data scientist, you have to work with the end goal of what is presented to you. Because there will be certain instructions, or yes, because now the reason for this instruction could be that, the marketing campaign will be like, we just want to target 3 sets of customers. We don't have much funds to distribute or marketing campaign, or too much funds to spend on marketing campaigns for more than 3 segments. I don't know if that's starting to make sense now. So they can just give you that instruction that, just focus on 3 customers, please. Our budget is not that much. So those are situations we can look at that situation and stick with one strictly. But in this case, we can choose to use 3 or 4 because the slope is going there. But the perfect, if you ask me, the perfect here is 4, actually, is 4. Because if you also trace back to the initial question, they were saying at least 3 species that are, I don't know if I can highlight this, but let's just follow my cluster. You see my cursor rather, you see, but they know that there are at least 3 species. So that means the species could be more than 3. So, and if we can get on to see that, oh, there is a situation where 4 can be considered, then why not? Because the team told us that at least 3, meaning that this could be more than 3. So I would want us to work with 4 here because 4 can help us uncover that there could be more than 3 optimal cluster for the situation. So, Mr. Deji, I don't know if that makes sense.
Yeah, it does. It does.
Or you have a contradicting point?
Yeah. No, I just use my intuition, like because I might be wrong, or I just use the distance thing to measure. Okay, that's.
I can't hear you clearly. It seems your volume seems to be a little bit down.
I think even like in the videos that we were watching, right, the instructor was saying that sometimes like there's no specific. Hello, can you hear me?
Yes, I'm with you now.
Hello?
It's clear now.
Yeah, even like the video that we watched in the modules, like the instructor was saying that there's no really specific number, that there's usually like a debate that okay, we want to pick, is it like the preceding number or the one after it, or is it 5 or is it 6, is it 3 or is it 4? But usually people just use like their intuitions to pick their clusters. There's no specific answer.
Yes, there's no so and remember your answer using the follow the elbow method should fall under this section, like where the graph tends to slope. Unless, like I mentioned, you have a constraint, and that constraint means the end goal is that, hey, we don't want you to do more than 2 clustering, we don't want you to do more than 4. If it's specific, then you know what to work with. I don't know if that makes sense as well.
Yes, it does. Thank you very much.
All right, no problem. All right, so number of clusters, we are going with 4. So the next thing, for time's sake, let's just quickly, we've come to the end stage. Thumbs up, guys, if you agree, we should just proceed to training the model with number of clusters that we've realized. Thumbs up. Okay, Mr. Simeon agrees. All right. Thank you, guys. Okay, so now we have a number of clusters to be 4. Let's go on and confidently use 4 to train the model. So we can still call this K-mean model. This is our final model because we now have an idea of the number of clusters to use. So K-means, okay, number of clusters equals to 4. Yeah, I see that I was going to explain random states. Now, random state is a situation that helps our model to be reproducible. Yes, especially for production. For production stage, we definitely have to indicate a random state because if we're not to indicate a random state, you find that the clusters or the clustering result you get tends to differ. If you're to rerun this, let's say you didn't indicate a random state, you just go ahead to fit and you cluster and look for labels. You think that it's not steady, it won't give you a constant clustering pattern. So that's why we always have to indicate this random state so that the same model as it is that we've trained this data set on remains reproducible if we're to run it another time. So going further, we impute our penguins scaled data frame. I'll be rushing a little bit now. We are a bit out of time. And that's it. We can now, I think we can now get the labels, which is the clusters it had been able to produce. But I'd always love to immediately attach those labels to our data frame. So in order to do that, we can just add that column for penguin scale data frame. Label is now equals to k means model dot labels. Yes. Dot labels. All right, please ask a question, Edmond.
Yes, good evening, Senior. So my question is, it's about the states. Why particularly 42? Like the number, is it that important, or it always has to be 42? Thank you.
No. You can choose to use any. You can choose any, but just make sure you indicate a random state. It doesn't have to be always 42, right? Yeah,
right,
Edmond, did you get?
I got you. Thank you.
Yes. It doesn't always have to be 42. Okay. Any other question? All right, no question. Okay, let's go on. So, I don't want to leave us behind. So let me quickly just print out what these labels look like before I just attach it. But I feel that attaching it to the data frame will help me explain better. So let me just go ahead and print the data frame so that we can see what has been generated. Scaled data frame. Thank you. Oh, we have clusters. Oh, clusters wasn't spelled correctly. Okay, that's corrected. A lot of mistakes. Oh,
Capital K.
Okay, yeah. I need to do
I think it's capital K.
Capital K. Capital K, right? Oh, yes, that's true. Capital K and small m. Oh, wow. I have a lot of spelling issues here. So this should work fine. Okay. Okay, I can see that. I always tend to misspell skilled. Did I do this? Oh, same thing here. All right. So that should do it. All right, fine. So quickly, you can see this newly created or added column to our data set. And what this means is that we have been able to come up with a lot of labels, like a lot of clusters. Sorry, not a lot, 4 in this case. That means we have clusters that are either grouped to 1 to 0, 1, 2, or 3. I'm trying to scroll down. Let me look for. Okay, I think I can get that without. Let me check for. Let me run this in order to visualize the number of. How do I do that now? Okay, let me use values count. Comment this out to prevent error. Snow values count, or do I run unique? Let me run unique. Right? I think that should be unique. unique. Okay, yes. So now, this tells us that these are the unique values we can find for that label column. And for label column, you find either a penguin belonging to 0, 2, 1, or 3. Like I put it here. I just wanted to use this to show us like the unique values we can find under that label column. So that's it. Let me reprint that now and let me explain further. Okay, I think I need to call the data frame in order to visualize. All right. Beautiful. All right. So that means the first penguin here we have on this data set belongs to cluster 0. The next belongs to cluster 2 and so on. And if we were to go on further, we see that some belong to cluster 1, cluster 3, in a total giving us 4 clusters. That's it. But now let's keep abreast with our question here, because like what else it needs to be done? If we've been able to come up with our clusters, what else do we need to answer in order to meet the criteria for this question? Now it says perform a cluster analysis. I think we've done that based on reasonable number of clusters and collect the average values for the clusters. Average values for the clusters. Now how? It says the output should be a data frame named start penguins. Okay, let's keep that in mind. We have to create a data frame called start penguins with 1 row per cluster. That means for each cluster, cluster 0, cluster 1, cluster 2, cluster 3, each of them should have their row in this data frame. Now, with 1 row per cluster, that shows the mean of the original variables or columns in penguins.csv by cluster. Let me explain this. So that means what they want us to do is we have to, at the end of the day, create a data frame where in this data frame, the rows we should have, each should represent each cluster. That means for row 1, we have 0. For row 1, we have cluster 1. For the next row, we have cluster 1. For the next, we have cluster 2. For the next, we have cluster 3. Now, the columns for each of these rows, the columns, let me see how well I can. Okay, let me format this. I think this should help us. Now, for each columns in these clusters, column 2, column 3, and so on, it should be an average for that particular cluster. Now, in this case, they said it says we need those columns that should be the mean of the original variables in that column by cluster. That means for column lengths, we should be able to have an average for the average column length in cluster 0, the average column depth rather in column for the next column. Yes, for cluster 0, the average flipper length or mean for cluster 0, and so on for the next. Now we'll put that into practice. And I think that's where we call off our meeting. All right, so let's quickly do that. And I missed out one of the instructions. They said start penguin should not include any non-numeric columns. And if you see, they say that we should get these original variables and columns from penguins.csv. That is the initial state of this file. And if you check, the initial state had an object column, which is what? Sex. Sex isn't how should I put it? A numerical column, or yes, a numerical column by default. We only did that artificially. So we have to drop this sex column before we can be able to meet this criteria. It says start English should not include any non-numeric columns. So that's what we do next. Let me create a new listing for that. And that would be, there are so many ways we can go about these guys. And one of the ways is that we can just subset for only the number of numeric columns we have in our data set. So we can name that, let me call that numeric columns. And what are the numeric columns we have there? Coleman. Okay, let me just copy them so that I don't have to start revisiting. Okay, let me do this in a very let me do this in a comfortable way. Which should I use? Penguin dummies. All right, let me use penguin dummies and see dot columns. What's it saying? Data frame columns. I think I don't have to call S. Okay, there's a double M here. All right, so it has to be columns. All right, so these are the 4 features we need to work with, including our label. Yes, because, and I'll tell us why we have to include the label, because in short, that's from where we can, anyway, we'll see the explanation as I go on. So I can copy from here now. Oh, okay, let me just copy this full array from here, and there you go. So I don't have to keep copy pasting one by one. All right, let me do this. Okay, and label. For uniformity, let me use a single. All right, label. Thank you. All right. So what next? Let's create our start penguins. What's it called? Our start penguins data frame. So now to create this data frame, we have to first subset for this number of columns, these numerical columns rather, that I've already initialized. So what this does is it just literally goes into this data set. Yes, it just goes into this data set that we have here now. It goes and pick each of the features I mentioned. That means it will pick 1, 2, 3, 4, and the label. It will leave out this one because this by default, this sex column by default, it wasn't a numerical column as the instruction says that we should leave it out. So that's it. And then, okay, let me print that out so that we stay abreast. Let me just quickly print that out so that we can see how true that is. Fine. As you can see, there's no sex column here. Fine. So what do we do next from here? The instruction says we should create a data frame whereby we have one row. We have each row representing each cluster. How can we go about that? We can go about that in so many ways, and one of it is group by. What do we group by? We are grouping by by the cluster or label that have been generated in order to help us meet that end goal. So what this does under the hood is, what this code line does is, it goes into this data frame, it classifies all of the features according to their label. That means it gathers all the data that belongs to group 0. That is to go pick this group, this 0, pick this 0, pick this one that belongs to 0, pick this one that belongs to 0. You can see my cursor. Pick this one that belongs to 0. Group them into one place. The same thing for 1, for cluster 1. It will go filter, check which of them belongs to 1, put them into one place. 2, the same thing. 3, the same thing. And now it waits for the next instruction. Now the next instruction is we need to get the mean for each of these features. So we run mean. And let's see what that outputs. Beautiful. Guys, you can see what I explained. First of all, this code line looks at our data set and groups them. That means it takes grouping. It groups them first by their label. That means label is the order it should start to group them by. After grouping them into this label, it runs mean for all the features for each respective clusters. So what this means is that for cluster 0, the average Kuhlmann length we'll find is this. The average Kuhlmann depth we'll find is this. The average flipper length we'll find is this. Body mass, the same for 1, for the cluster group 1, and so on. So I think this is the end of, like, there's nothing more we can do unless I'm missing out on something. I don't know if I'm missing out on someone. Someone please indicate if there's something we are leaving out of the table. I think we've answered all the questions. Check, we've been able to create a data frame, because this is the data frame. In order to confirm if it's the data frame, we can run type. Let's run type on this to see if what we have is a data frame. Beautiful. Type says this is actually a data frame. All right. I cleaned a lot of things. Okay. All right, Mr. Adedeji, please go on.
Okay, sir. So you're using the scaled data to compare your labels with your features, but how do you particularly know which one has like dominance, which feature has more dominance in the cluster? Because there was this one that they used where I think they used crosstab to compare our labels with our features. So we can say that, okay, maybe 30 of this one that has, maybe 30 of the penguins in label 1, they have more of these features or something. So I'm thinking, if I'm using skill data to compare, how would we particularly know which one has distinct features than the other? That's my question.
Okay, so if I get your question correctly, you are saying, why don't we use the data that before standard scaling, right? Why don't we use this particular data set?
Yes. Actually, so that we'll be able to maybe see patterns when we are now comparing our labels with our features.
Okay, the actual patterns that is going on. Oh, yes, we can actually do that. It all depends on the instructions. Let's do that and let's see how that comes out. Yeah, it's typically the same code. It's the same code. So I'll comment this out, and I guess here will just be penguins dummies. Yes, penguins dummies. But the problem now would be Okay, let's know it's not a problem actually. I will need to add this to the penguin dummies. What's it called? Add that so that when we group by, it doesn't throw an error that you can't find the believer column on penguin dummies.
Sorry, sir.
Yeah, Hakim, you want to say
Sorry
something?
to Yes, I'm sorry to interrupt you, sir. I actually have
Okay.
another meeting by 8:30, so
Okay.
I want to leave the call.
All right. Just send me a DM on WhatsApp so that you can fill this thing later. Because once I'm done, I'll just drop the link. We're already done, so I'll be dropping it in no minute. But since you have to go, just get me on WhatsApp so that I can leave it with you.
Okay, thank you very much, sir.
All right, you're welcome. All right. So let's kick off with Deji's suggestion. All right. So Deji, is this what you're talking about?
Yes, exactly. This is it. Something like
Okay.
this so that we can
Okay.
all
Okay.
keep
Okay.
our
So all right. So we can definitely do it like this. Sometimes it all depends on the instruction. So from the instruction, we weren't told that the data frame has to be used on the scaled phone or it has to be, but for human readable or to draw an insight as a human, because if we were to use the scale data, that means that's if we want to do something more with the machine. But at this point, I think we're done, and we just want to see, okay, from the clusters in this cluster, now the inside will make more sense. And thank you, Deji, for that suggestion. The inside makes more sense that from this Coolment length for cluster 0, the average Coolment length there is 43.8. That for the cluster 1 is 45.56, 40.21 for 2 for cluster 2, and 49.47 for cluster 3. So it all makes sense now. It's now human. It's now, how do I put it? It's now human, more human, insightful to look through it this way. So anyone else, any question? I think we've come to the end of it. We've come to the end of this section. Does anyone have any question? Any question, please, so that you can quickly fill the form and take our leave. Doba, you want to say something or ask a question? Okay, Mr. Simeon, go on, please.
Okay, so my question is, I was thinking that we will convert this data frame to a CSV file.
We will convert what?
This data frame start penguins to a CSV file.
To a CSV file.
Yeah, that's what I'm thinking. Yeah, I'm seeing that it's saying columns in CSV. I don't know.
Well, that depends. If we can find out on this instruction, why not? But if we look through the instructions so far, like from import, investigate, preprocess, begin a cluster analysis based on reasonable number of clusters, collect the average values for the clusters. The output should be a data frame named start penguins with 1 row per cluster, blah, 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 by cluster. Start penguins should not include. So far, there's nowhere they indicated that we should convert start penguins to a CSV. So we can do that. That's based off the instruction. So, Mr. Simeon, I believe you can agree with me now that it's not necessary we do that since there is no instruction to convert to a CSV, right?
Okay, yeah, I agree.
Yes. All right. Anyone else? Any question? All right. We'll be rounding this up. So I will quickly drop the form, and there's something I observed that we didn't do, which is also vital. I'll just quickly do that. But meanwhile, I'll drop the link for us to fill for attendance. Okay, dropping right now and launch. All right, so guys, just quickly fill in the attendance for today. Why I make comment on something we might have missed out. So before we go further to please, I need your attention while you fill the form as well. Before you go, before you even go further to do this, like create a data frame and achieve the instructions that have been mentioned, I think we skip the part where we have to visualize our clusters. At least let's see what have been, like, the clusters that have been created so far. I'll quickly do that. We can do so using plt.scatter. They're using the scatter plots. And we'll do penguins scaled data frame label. Penguins scaled. I always seem to misspell scaled. I definitely need to sign up for the spelling class after tonight. I need to fix my spelling as soon as possible. Coolman MM and C is equals to using our labels. Okay, that will be capital K mean model dot labels. I would have gone to just label this, but they'll be out of time. Let me just quickly show so that we can see what is generated so far. Another spelling error. Please, guys, if anyone can recommend a spelling course for me, I would really appreciate. I don't know why I keep misspelling skilled, for goodness sake. All right. So let me take our attention, Mr. DJ. Please, Mr. DJ, don't, but if you have a spelling course to recommend, just send it my way. So I stopped misspelling. Okay, my full name is Paul Silas. I've dropped it on the chat, Paul Silas. All right. You're welcome, Salim. So as we can see now, we have, this is the clusters, the 4 clusters that our data set was able to output. And we can plot this in different patterns. Like we can choose to plot, instead of putting the x axis to be the label, we can just put I think there's Coleman depth as one of the, what's it called? It's in Coleman. Beautiful. So this, you can see that how these clusters were generated. You can tweak this. Let's say, what's the other one? Is it flipper? Yes, flipper length. Flipper length. Is it flipper depth? Let me try length first. Okay, it is flipper length. So guys, you can see how I'm generating a scatter plot. By the end of the day, we tend to see 4 different clusters that have been created, indicated by the colors, the coloring, which we used by indicating this C label. This C label. If that C label wasn't to be indicated, we will see that there will be no clustering. Sorry, there will be no indication for color. You see, everything just looks like they are actually the same, but they are not. So until we tend to include that C feature into this scatter plots, we can see a coloring that indicates there are certain clusters that belong to yellow, brown, green, and blue. And we can plot this for different. I think this should be named body mass. The other column we had there is body mass. I think it's just body mass. Or is it body mass slash G? I think it should be body mass slash G. Maybe I have to go and recheck. Body mass, fine. That's body mass slash G. Yes. All right. So, anyone has any question? We've actually done with today's class, and I hope everyone was able to go along or follow along rather. Any question? Any question? No question? Any question? No question? Anybody? Okay, so I believe everyone followed alongside, and yeah, we have to call the meeting off. We have to call the meeting off. We have to call the meeting off. Doba, you're muted. You want to say something? Doba, are you there? I think Doba is not even here. Oh, that's fine. So, guys, that's it. And before I forget, please, let me add a few things. Now that we are done with unsupervised learning, please just get on with the next course. Don't wait for maybe assignment to be assigned for the next track. Just move with your pace. Do you understand? Move with your pace, gather your questions, and wait for the next session so that we can all pull heads together and discuss like we just did today. I believe that pattern of learning is more better than just waiting for these courses to be assigned to you. And next, I encourage us to also join the Discord group. Join the Discord group because there are certain information that will be left there. And when I mean the Discord group, not just the Discord group, I mean the what's it called? The channel on Discord that is meant for us, the AI stroke machine learning specific channel, so that you can able to find specific instructions or guides or help. Because sometimes I could be free because I'm thinking of doing that this week. I can just come on the Discord. We open up a very short hangout. There's a section for hangouts, and we just discuss certain things about machine learning. It's not course data camp related. We can just talk about career paths as a machine learning engineer, talk about you understand all those tips that helps us learn fast, practical situations about in machine learning. So please join the AI Discord channel. I might get started on that this week, and I also pass that through my other teaching assistants. If they have the time, we can do this so that you can also fast track our learning as well. It will be more of a discussion hangout. So, all right, Mr. Adedeji says, sir, can you take us on NMF test vector risers? I think that's natural language now. We are now going into Mr. Adedeji, isn't it? We're now looking at natural language. If you look at
No,
text
sir.
vector
It's in the unsupervised learning module, right? And I kind of
okay.
struggled with it after we did K-means, they now went to NMF and I think
Okay.
CSNE, CSNE and text vectorizers. So I kind of struggled with it to kind of understand deep inside. So I was maybe hoping that maybe if you were going through unsupervised learning, maybe you'll just branch there to just give us like an abstract because it's in the module.
Okay. Well, I can quickly touch on that, but that explanation it's much technical, and it's that way we are looking into a bit of natural language processing, and I need to start mentioning things like TF-IDF, bag of words, and topic modeling and the rest. That explanation seems a bit technical, but let me see if we can have that Discord hangout this week. I will touch on it since like if you'll be around on that Discord hangout, I can just touch on it because if I'm to wait for that natural language time, I think it's a long time before data camp. Before you start doing natural language on data camp, it's a lot. It's like doing. You have to do some other courses first before you get to that. So yeah, this hangout. Let's just hopefully I get the time. We can discuss that during the hangout, Deji. Okay, so just remind me. All right. So any other question, anyone, please? All right, no question. So I will bid us all good night. Thank you for attending, and don't be late for next week hangouts. All right. Have a great weekend. Have a great Sunday tomorrow. Have a great week ahead. And I might not be available for the next, I believe the next course is a fresh new one, and it will be a new tutor or TA that will be taking you on it. My battery is very low, self. All right, so good night, everyone. Take care.
Sorry, so any update for me?
Yes, Deborah. Yes, there's an update for you. There's an update. Yes, an update.
Okay, sir.
Yes.
Sure.
Okay. Just remind me, we'll discuss that on the DM. Let's discuss that via WhatsApp. Okay.
All right. Okay, sir.
All right, no problem. Thank you for reminding me.
Thank you, sir.
Hi, Mr. Silas. Please, Mr. Paul, can I get your number, please? It's still here.
Oh yeah, Emmanuel. Okay. I will leave that on the chat.
All right, thank you. Sorry, which of the chats? Do you mean in call messages on the meet on the call?
Yes, in call message on the meet.
All right.
All right, I just dropped it.
All right, thank you.
Mr. Samuel. Okay, let me repeat the link for Samuel. I dropped it earlier. Samuel, I dropped the link again for you to see. And also, my full name is Paul Silas. I think you might need that to fill in the attendance.